Hey everybody, and welcome back, or if it's your first time here, welcome to this channel. I'm David Townsend. This is the Net Academy, where we are learning networks together. And on this video, what we're going to go through even more is BGP, or Border Gateway Protocol. And I've said this quite a few times, but this is a massive protocol. It's absolutely enormous because there's a lot that we can do with BGP in terms of configuration, manipulation, policies, route distinguishers, route targets, and so much more. And generally, it's just what makes the internet works. And as I've said before, it's in the data centers, it's in the enterprise networks, it's in service provider networks. It's literally everywhere, both between different types of networks and in some cases inside the networks themselves. And what is fundamentally essential to BGP, to any routing protocol for that matter, is to have a way of understanding, learning, and determining what's the best route or the best path to get to any given destination. And in the BGP world, that is the path attributes. Now, if you don't know what the path attributes are in BGP for the Juniper Junos devices, and please check out this link. It's the video I done which goes through what are the path attributes, and the first few path attributes, which is the local preference and next hop plus one other. But what we're going to do in this video is actually concentrate on the next two path attributes after those local preferences and the next hop. And for that, this is the important AS path, or autonomous system path. Now, I don't want to go into this too much too soon, but AS path is really the big tiebreaker, because what it allows to do is for that router, that BGP speaker router, to determine what is the shortest path essentially to get to that destination, and thus pick that shortest path. But it's also a loop prevention mechanism. And next, after we've done AS path, we're then going to go into the origin code. What are the three different flavors of the origin code? And of course, how can we manipulate that origin code on the Juniper Junos devices? So if you like this video, please give it a like. Please subscribe to my channel. I release new content weekly. Other than that, let's just get straight on the lab and let's get going. And so here's a table that I just grabbed off one of the Juniper websites. The link is down at the bottom, but it really describes the BGP path selection process. And basically that process is going from one to the next, to the next, to the next, until eventually there's a tiebreaker, whatever that tiebreaker may actually be. And that is how the routers can essentially decide and determine what is the best route to get to that destination, wherever that destination may be, based on those particular attributes which you get in that update message. Again, if you don't know what the update message is, check out this link. But from a high level point of view, what the very first thing, and it's not actually shown in this table, that the routers will actually look at is the preference of that particular routing protocol. In the Cisco world, this is known as the administrative distance. In the video I've done before, I called it administrative cost, but essentially the same thing. But what we're basically looking to do here is see what is the preference of that routing protocol. And the whole point of that is to determine, well, based on that preference value, such as 170 or 15, 17, if we're talking about OSPF, then that will actually be lower, i.e. more preferable than that in the Junos world of BGP. So in the Junos world, BGP has a preference of 170. So the preference is always determined first before this whole path selection process actually does begin. And thus, in the Junos world, OSPF, ISIS, and others will always be preferred over BGP, and unless, again, you manipulate those attributes. What comes next, though, after the preference is next hop. So that next hop is where those packets are actually going to, and that has to be reachable, it has to be resolvable. If it's not, then even if that preference is the best preference for that given route, then if the next hop isn't reachable via that routing protocol, then it's not going to be used in the forwarding table itself. But let's just assume that the preference points to BGP and that the next hop is reachable. What happens is that the routers will go down to the first step and determine what is the best or better local preference. So this is something that's advertised inside of an autonomous system to all other BGP, iBGP specifically speaking routers, and the default is 100. Higher the number, the more preferable it actually is. So if both routes, or if all routes have this default value of 100, then it's going to go on to the next part. And between here, there's actually another step called the accumulated interior gateway protocol. Bit of a tongue twister there. But if you don't know what that is, just check out this video. It's down in the description box as well. But after we've done the iBGP, we're then coming on to the shortest autonomous system path length. And that is actually the first part of this video. And if both routes of all routes to that destination have the same AS path length, and I'll come on to this in just a bit, we're then going to move on to the origin code. And it keeps doing this and this and this until eventually there's a tiebreaker, i.e. one route is of better value or better preference or shorter AS path length, etc. and is thus more preferable for that router to actually take. And here's the network here, and I've been using this for quite a few videos now. But the general scenario is we've got Enterprise here in ASN 65200 and Enterprise A here in 65100. Both of them are connected via two different paths as such. We've got one direct path through service provider 1, and then we've got another direct path that goes through service provider 2 and service provider 3. And what I've done in Enterprise B is on R18, R20, R21 and R19 down here is I've injected a static route. So say just for example on R19, that is 19.19.19.19/32, and that's the same for all the other routers. So R18 will be an 18/32, R21 will be a 21/32. Obviously you get the idea, but all of these are exported into BGP, and then these are advertised across the network, across the service provider networks into Enterprise A. And so these routers here can actually see to get to these routers over here. So those static routes are acting like a loopback address to easily identify which router is which. But to actually get to these routers over here, I've got an AS path length of going over here and an AS path length of going over there. But what is this AS path length? The AS path length is something that is accumulated as it goes through one autonomous system through another autonomous system, i.e. it increases in length. So if we look at it from the bit of a longer route, where say we're going from Enterprise B through Service Provider 3, Service Provider 2 into Enterprise A. Now when that route is injected into the routing table, so say at R19 here, it will have I, which stands for internal, it's where it's actually originated from, and then it will have 65200. So what that means is that this route has originated from ASN 65200. But then as these packets go into Service Provider 3 and Autonomous System number 3, that AS path is incremented again. But it's not actually technically incremented until it actually leaves this service provider network. The egress router will actually add its own autonomous system number into the AS path. So no internal iBGP speaking routers will actually do that. It's only the egress routers outside that are going out of the autonomous system that will actually do that for you. So as these packets are going out of this autonomous system here, it is then incremented in length. So it's now taking ISP3, we've got 3, 65200 and I. So you can actually see just there it's incremented in length. And again, as these packets go through the network here, these routers can see, to get to R19 or to any router in Enterprise B, it's going to cost me, or that AS path length is essentially 2. I've got one hop here. I don't want to call it hop, but it's essentially hop, and another hop here. It's kind of a hop feel. It's not really a hop as such, because a hop just means one router, whereas an autonomous system, they could be several tens, maybe even hundreds of routers, but it's all recognized as the same autonomous system. But we can see from these routers' perspective that I've got to go through Service Provider 3's network, and then I get to the actual origin itself. But when these packets are then updated into Enterprise A networks, all these routers here will learn, specifically these routers being the egress interfaces, sorry, the egress routers, they will learn that the cost to get to say R19 over here is 2, 3, 65, 200 I. So then it can actually see it's got to go through 2 autonomous systems before it actually gets to that destination. But if we actually compare this to the top path, the top route, i.e. if it's going through service provider number 1 into enterprise A, as those update messages come in here, it is again 65 200 I, and as those packets and update messages are advertised into enterprise A over this link here, it then becomes 1 65 200 I. And then you can really see the difference in the AS path length. So if I just quickly summarize that, what we can now see is the AS path length on these routers. So these routers would know to get to any destination in enterprise B, it has got potentially 2 routes available to it. It can go via this route here, where it's got a AS path length of 1 and then 65 200, so essentially 2. Or it could go via this route down here, but it's a bit longer, so 2, 3, and then 65 200. Which one is going to be more preferred? Obviously the shortest path. So then these routers here will prefer router R5 to get to that destination based on the AS path length because it is shorter. But what's also really interesting about the AS path length is the way it's able to actually detect a loop. So say this wasn't 65 200, say this was, just for example, 65 100. So the same ASN as enterprise A. Just say, for example, that these messages were sent from enterprise B into service provider 1. We would have I 65 100. Then those update messages would go throughout the network here and eventually come down to R1, and then R1 would think, hang on, I'm connected to 65 100 over here, but the origin is 65 100, and if I send this out again, it's also going to go to 65 100, and therefore there's a loop somewhere in the network. So 65 100 here and 65 100 there, there's a loop. So what happens is that R1 is not even going to send those packets. There is a way to get around that, and that is the advertised peer autonomous system, where on the routers facing that enterprise network, you'd have to enter this command, which allows them to advertise the same autonomous system into that autonomous system in terms of the number. But also on these routers here, you'd have to configure the loops command as well in the routing options. I know it's a bit out of topic there, but if you don't know what I'm actually talking about, just check out this video. It's all explained there. But this is essentially how the AS path length also acts as a loop prevention, because if the routers detect and see that the same autonomous system number occurs within that AS path length, then it could indicate a loop. And I say could because what we can do and what we're going to do in the lab is we're actually going to manipulate the AS path length. We're going to start letting the router decide from enterprise A's perspective, do I want to go this way, or actually do I just want to go this way? And there's different ways we can go around that, and actually let's just jump on the COI and actually start showing that. So I've just logged on to router R5 on my secure CRT, and router R5 is just over here, just so you know where my mouse is currently pointing. And let's just go into the command line interface, and now let's just do a quick show route. Now I've tried to minimize the table as much as possible because I appreciate this is quite a big lab, but what we can see, and actually I am just going to make this a bit bigger, but what we can see is R18 here, we can see R19, we can see R21, and if I scroll just back up we can see R20. So that, again, those are the static routes I've injected into these routers in enterprise B, and are seen through service provider 1 and through service provider 3, service provider 2 into enterprise A. The reason why I know that is because if we just look at R18, just for example here, we can actually see the AS path length. Now note the asterisk here. Asterisk means that this is actually the chosen route. So you can actually see we've got 2 routes here, but this is the chosen route. And what you can actually see is BGP, so the protocol is BGP. Here is the preference, so the preference of 170, as I said before. This is how long it's been active in the routing table. The local preference, so that is the first part of the BGP path selection process. The default is 100. It's also a default of 100 down here. So then it might have moved on to accumulated IGP. Again, it's a tongue twister. But again, that's pretty much of a niche niche selection process, not typically used. So then it's gone on to AS path length. And now what we could see is the AS path here. So this chosen route goes through service provider 1, service provider 1 again, and then up to 65,200. I will explain why you are seeing two ISP1s or two ASN1s here in just a few minutes, don't worry. But you can see here ASN1, 65,200, and that's where it's originated from. We can then see the other route it could take. So 2, service provider 2, ASN 3, service provider 3, till then I get to 65,200, which is where it originated from. Why this is chosen as the best route, that would be some tiebreaker in that BGP path selection process. It might be the IP address, it might be the router ID, one of those really bottom ones, because everything is default, everything is typically the same right now. But this is actually the chosen route. So as I said, I want to just explain to you why we are seeing two autonomous system number 1s, because as you can see on the lab, there is actually only one. And this comes back to manipulating the BGP path selection process. And to explain this, what I've done is I've just logged onto router R1 here. Now, as we saw on router R5's routing table, it had 1, 1, and then 65,200. But as you can see here, there's only one autonomous system number 1. So where is this extra one actually coming from? This is coming from router R1. Because the AS path length will naturally choose, or the routers I should say, will naturally choose the shortest AS path length, by default R5 and all the routers in Enterprise 8 would choose this route as opposed to this route down here, because it would be the shortest route. So what I did on router R1 is I injected, or I created a policy in policy options, a policy statement called AS path, and then I said under term 1, then AS path prepend number 1. That's it. Then what I did is I injected that policy statement that I called AS path, I injected that into the external group of BGP, I for R5, which has that period between R5 and R1. So from R1's perspective, what it's then doing is it's then adding an extra 1 to the AS path length. Because of that, this router down here can see, I've got two autonomous systems to get to Enterprise B, and R5 will see, I've got two autonomous systems to get to Enterprise B as well. And then they can maybe start doing some load balancing with additional configuration on the forwarding table. Or what you could actually do is just do it for a typical routing policy, for a particular network or particular prefix. We'll come on to that in just a second. So what happens if I actually remove that policy statement from router R1, which is adding in that extra autonomous system number, i.e. AS1, into that path list? Let's see what happens. So I'm just on router R1 here, and that's just this router up here in ISP1. And all I'm going to do is I'm just going to go into Edit Protocols BGP Group External AS65100. Let's do a quick show, and you can see here is that policy statement that I need to remove. And just to refresh, if I just do top show policy state options policy statement, get it right, and let's do AS path, and you can actually see this is the term here. So AS, then term 1, then AS path prepend, I add 1. Literally add AS number 1. If I'd have done 1111, it would have added 1111 to the AS path list. But anyway, let's actually delete the export of AS path, and let's do a show again, and you can now see that it has been removed. So it was up here and now it's no longer there. So let's just do a commit on this. So with that now committed, let's go on to router R5 and router R10 to see what is happening in terms of their routing table. What are they actually advertising to other routers? So let's go onto router R5 first, which is here. And I'm just going to refresh the page. Let's just do exit on that. And so with the routing table now displayed, what we can see is quite a few different things. So we can actually see, first off, one thing that jumps to my eyes is if we look at the 19/32, we've still got two hops, we've still got two paths to get to that destination. And it's actually chosen to go through the service provider 2 and service provider 3 network. Now, why is that? It's because the local preference is 101. Local preference is configured and checked before AS path. So that is why this path between ISP2 and ISP3 to Enterprise B has actually been chosen. But if we look at all the other networks, i.e. 18/32, 20/32, 21/32, we can now see only one path to that actual destination, i.e. go through ASN 1, service provider 1, and then we get to the actual origin, which is 65/200. And that is just very quickly how we can manipulate the AS path list, because before we saw 11 65/200, now we only see the 1 number, ASN 1. But let's actually just go back. Actually, let's go into R10 and see what is happening here. So if I do CLI and let's do a show route here, we can see pretty much the same information here. We've got, the 2 routes to get to R18 here, 2 routes to get to R20 here, 2 routes to get to R21 here. Why is it saying 2 instead of 1? Well, don't forget we're en route to R10 down here. So R5 is advertising through to its autonomous system. If you want to get to R18, R19, R20 and R21, you can still get through me, and actually I've only got 1 autonomous system that I actually need to go through. But if we actually look at the paths that are chosen to get to, say, R20, you can again see from R10, it's going to use the path through R5 because it's saying my egress interface is gig E002 to 192.168.10.9, which is this interface up here. And again, just to reinforce that, we can see the AS path here, 1, 65/200, and then the origin. But let's actually see, this is what I find really cool with BGP and the routers in Junos. Let's see what R10 is advertising out. And this is important because if I now do a show route advertising protocol, BGP to neighbor 200.10.100.5. If you don't know what that is, that's basically the loopback address on router R5. iBGP is built using local loopback addressing. If you don't know why, just check out this video, it explains why. But what you can see here is that it's not actually advertising the 18/32, the 20/32, the 21/32. I probably just want to do a little bit of investigation why it's still in advertising the 19, probably because of the local preference, I'd imagine, which is fine. Why is it not advertising the 18/32, the 20/32, the 21/32? And the reason is it just purely comes back to that AS path. If we look at it from R5's perspective, it knows to get all the way over to the destination. So say the destination is R18, so the 18/32 that we saw, it's the AS path was quite literally 1 65/200I. And this is advertised to all the iBGP speaking routers, including R10. Now at this point, R10 can see, I've got 2 routes, I've got 2 ways, 2 paths to get to R18. I can go up this way, or I can go via here. But that AS path list would be 2, 3, 65/200I. So obviously, because of this extra number here, it's larger. And because R10 knows that this is the least preferred path, it's then not going to advertise that path out to all the other speaking routers, iBGP speaking routers in the autonomous system. It's not going to do that because then these routers, they don't need to know, well, you've got a least preferred path to get to that destination when I can just use this path. I'm just going to install that in my routing table, so don't bother advertising it to me in the first place. But obviously, if this link goes down and R5 loses all connectivity to Enterprise A, suddenly it would update its neighbors saying, oh, hang on, I'm withdrawing all those prefixes, R18/32 from the update message from my routing table. And R10 is suddenly going to step in and say, hang on, I can get to R18 via this route here. And now I'm going to start advertising all of my routes that I can reach to you, because now this is more preferred. So let's come up with a scenario of how we want to manipulate and configure the AS path and the attributes, the prepend of the AS numbers to the AS path list. Let's say for 18 and 20, the /32, so R18 here and R20 here, let's say we want all of Enterprise A's routers to use this path here. However, for the 19/32 and for the 21/32, we want all the routers in Enterprise A to use this path down here. How can we actually do that? And this is to enable us to have some kind of load balancing in an active-active topology. So first let's go on to router R1, because for the 18 and 20/32, i.e. R18 and R20, we want to add the AS path, those autonomous system numbers, to that path attribute as it's been advertised out of service provider 1. So we need to go into router R1 to configure that, so when R5 in Enterprise A receives those update messages and those path attributes, it's already got that ASN path list with the addition of those attributes. We could also do it on R5 as well, then advertise that into iBGP, but just to keep things simple, I'm going to do it on router R1. So to do that, it's very simple. Now we want R18 and R20 to be preferred to go through service provider 1, which means we need to make R19 and R21 less preferred. So we need to add the path list to those networks. So let's go to the top and let's do edit policy options, and just do a quick show just so we can see everything we've got. And you can see I've already got a policy statement actually configured here, so I'm just going to edit that policy statement itself, and I just had a few errors there, so I'm just going to do a quick show again, and here we go. Very simple. Now what I want to do is I want to filter down on those specific networks, those /32s. So I'm going to do set turn 1 from root filter, and now I'm going to enter in 19.19.19.19/32 exactly, and I'm going to do the same for the 21, and there we go, the root filter 21 I think /32 exactly. And now if I do a quick show, you can now see what we've done here is we've said for anything that matches exactly 19/32 and 21/32, then add AS path 1 onto that path attribute list. Now obviously I want to show you a bit more than that, so if I now do set term 1 then AS path, and if I hit question mark, you can now see there's two different ways to actually add an autonomous system number to that path attribute list. So we can expand or we can prepend. To be honest, they both pretty much do the same thing. Both are for BGP only, obviously. But here we prepend in AS numbers prior to adding the local autonomous system. So say if I done expand and hit question mark, you can now see I can add in the last autonomous system number again. So that would be 65200, because that would be the last autonomous system number. So what I'm going to do is last autonomous system, and you have to do count. So I'm going to do count 5, and there we go. And let's just do a quick show. And now what you can see is from 19/32, 21/32 exactly, then AS path prepend 1 and expand last autonomous system by the count of 5. I probably just want to get rid of one of these, so just to make it more interesting, I'm just going to get rid of this one because they pretty much do the same thing anyway. This one is saying I want to add in that autonomous system number, whatever was the last one in that path attribute list, 5 times, and this one is saying, well, add in 1 once, or add in 1 2 times, however many. So for that you'd be AS path prepend 1 if that makes sense. So I'm just going to do delete term 1, then AS path prepend 1, and let's do quick show, so make sure it's there. And now if I just go to the top and do edit protocols BGP group external, let's do show, we can see that it's not in the export list here, so I just now need to do set export AS path. Let's do show again. We could see it's here, and let's now commit that configuration. So what we now should see is that the routes going to 19 and 21/32s are no longer preferred to go through service provider 1 because they've been prepended. They've had quite a lot of autonomous system numbers added to that path attribute list. So now all these routers to get to that 19 and 21/32, they should be going via service provider 2 and service provider 3. So let's go back onto router R5 and see what is actually seen, what is received from router R1. So R5 is here. We've done the configuration on R1, which is here. And on R5, let's just do a show route to keep it nice and simple. And let me just scroll back up. And what we can now see is, look, 19.19.19/32, the preferred path, again, the asterisk, is to go through service provider 2 and service provider 3. And then we get to 65.200. There is, of course, the backup path to go through service provider 1. But note the amount of times we have added that last autonomous system number. Again, that last autonomous system count was, I'm going to add in whatever the last autonomous system number is in that path attribute. I'm going to add it in 5 times. So if I scroll back up to R19, before I've done that configuration, you can actually see here that it was 65.201. Now from R1's perspective, which is in autonomous system number 1, all it saw was 65.200, and I can back that up by just doing a run show route, and you can actually see here to get to 19 is just 65.200. So what R1 was then doing is it's then adding that 65.200 and 5 times, because we done AS path expand last autonomous system count 5. So it then took that last autonomous system number, added it once, twice, 3 times, 4 times, 5 times before adding its own autonomous system number and advertising that into Enterprise A. So what about R18 and R20, i.e. the 18/32 and the 20/32? Do we need to do anything? The answer is no, because we've configured R1 for the 19/32 and the 21/32 to be really less preferable, and thus all the routers in Enterprise A are going to take the Salvan route. They're going to go through service provider 2 and service provider B to get, service provider 3 to get into Enterprise B. However, for the 18/32 and the 20/32, you can actually see that it's only got one path. Now that is correct, because we have got the path attribute list, the AS path of I/65.201, and again for 20/32 we've got I/65.201. Why is he not seeing the other one? Well, remember, the other route to get to Enterprise B. Well, remember what I said at the beginning, where R10 is not going to advertise in those networks which are less preferred, because R10 knows that to get to R18 and R20, R5 has got that more preferred route, that shorter AS path list to get to Enterprise B, and thus it's not going to advertise out yet unless this link goes down. If you want to get to these networks, you can go through me. So that is the AS path list, everyone. That is how we can manipulate, change, alter the BGP's path selection process in the Juniper Junos devices. As you can see, there's 2 different ways to do it, but both are very straightforward. All you need to do is define a policy statement which is going to take that particular route filter to filter on a specific subnet or network, or in this case a /32 address, and then do an AS path prepend or expand. Both will do exactly the same thing in terms of adding in an autonomous system number to that path list, but then you need to export that into BGP itself. But that is the AS path, and that is how, as you saw, we can influence that BGP path selection process in the lab. So let's now move on to the next part of the video, which is the BGP origin code, or just origin for short. Now let's work off the scenario where everything has been okay so far. So we've had the next hop has been resolvable, and BGP has been selected because of that preference, i.e. 170. So that router will use BGP. Now, also, if we then move on to the next part of the scenario where the local preference has been the same for that router to decide which path to actually go to. So we've had at least 2 paths to get to that destination, and both of them have had that same default value, or whatever that value actually is. So then it will move on to the next part, which is the AS path length. Again, we're always looking for a tiebreaker here. So let's assume that that AS path has been the same length for those same paths to that same destination. And now we move on to that origin code, which is the third part as such in the BGP path selection process on Juniper Junos devices. So what is the origin code? It is really how it sounds, to be honest, is where has this actually originated from and how trustworthy is that origin code itself? And I just said a word, code. There are actually 3 codes that you need to be aware of when it comes to the BGP origin. First is I, or internal, or as it's also called, IGP. So either internal or IGP is referring to a route, a network, a prefix which has been learnt internally within that autonomous system via an internal gateway protocol. So say for example we've got a network here and that's been advertised into BGP. That would be an origin of I, because it's something that's been learnt internally within that autonomous system itself. The next one is E, and this stands for EGP. Honestly, this isn't even worth wasting my breath over or even wasting your time over, because it's not seen in networks today. You will never, ever see E in the origin code. If you do, let me know, because I've never seen it and I don't know anyone that has. So that's as much of my breath as I'm going to waste on it. The third and final origin code is the question mark. And what this stands for is incomplete. So what's the difference between IGP and incomplete? Well, if you look at it from this router over here, say it's advertising a route all the way through the network here and onto these routers down here. And I'm just going to do that way as well. And I've put the autonomous systems at the top. I 65200. Then as we know, as it leaves autonomous system 1, it would be I 65200. I'm running out of space. 1. And then as it then left autonomous system 6500 to whatever was connected to here, it would be 65100 1, and then 65200, all in the same line. I'm just running out of space, and then I. So that means that this is very trustworthy, because this router over here has originated that prefix, has originated that destination, whatever it may be. But what if it's a question mark? Well, it would still have the same AS path lengths as it goes through the network itself. And I've just changed my marker just so we can see things a bit clearer. But let's look at it from a path selection process. So let's say the 65200i, i.e. something that was internally learned, something that originated internally to this router here. Let's say this router here is doing some kind of manipulation where it's forwarding that I 65101 down to this router here. At the same time, it's then doing manipulation on that question mark here, where it's saying, I'm going to send 65100, or sorry, 65200 question mark to this router up here. Now, what would actually happen is that this router here would not prefer by default this route. Is actually going to prefer to go the long way, because this one is more preferable. And actually this router here would advertise up to that router, because they would have the same AS path length. This has been internally learned, whereas you've got a question mark, and thus it's less preferable. So then we can actually manipulate and change even the routing behavior on routers themselves. But what you have to remember is that I is more preferable to E. E is never seen, so I is always going to be more preferable to question mark. Why would you want to change the values, change those codes? As I just explained, really, it's all about manipulating the paths that routers choose to get to that end destination. And you can do that for an entire network, for an entire prefix, or for specific destinations, i.e. /32s, using policy statements. But that's really what the origin code is. It's how trustworthy is that code, is that origin. And just to be clear, what the question mark or incomplete actually means is unknown. That origin code is unknown. So in the Junos world, it's actually very hard to come across that question mark, because typically if it's something we're exporting, like a static route or an IGP, such as OSPF, if we're exporting something like that into BGP, that means we know where it's came from, and as such it's going to be an I, or IGP/internal. So it's quite hard to come across the question mark. However, you can change that default behavior in Junos, again by using policy statements. But just always remember, I is the most preferred, whereas the question mark or incomplete dash unknown is the least preferred out of all the origin codes. And now let me show you how quick and easy it is to configure or manipulate the origin code on Juniper Junos devices. I kid you not, there is actually not much you need to do to actually manipulate that code in itself. But let's just start off, and for your information, I have just zeroized the last configuration I've done on AS Path. So if I just go back to R5, which is this router just here, and do a let me first log in. So let's go into CLI, do show root, and what we can see for 18, 19, 20, and the 21, you can see there's no crazy numbers for the 65200. I've completely removed that configuration. Why? Because the origin code comes after AS Path. So some of these routes would be chosen, would have that tiebreaker before we even hit the origin code in terms of the path selection. So I've just got rid of that. As you can see, they all of these 18/32, 19/32, etc. have the same length in the AS path. Through the autonomous system 1, we've got 3 autonomous systems before we get to the origin. And for the other path, going through service provider 2 and service provider 3, and then we get to the origin again itself. So all things being equal, we can now play about with the origin code. So where are we going to configure this origin code? Really, it all depends on the policies themselves and where you want to do that manipulation. You might want to do it as it's leaving Enterprise B, or maybe you want to do it in the service provider network itself, or maybe you want to do it in Enterprise A before it's then shared to all the other iBGP neighbors. So there's a lot of different places that obviously you could do it, not to mention in these 2 service provider networks down here. But what we're going to do is we're just going to keep things a little bit consistent, and we're going to say, well, okay, we want to do the manipulation just like we did with the AS path in a service provider network. But more than likely, you're probably going to do it on the router or in the network where it's actually originated from. But just to be consistent for this video, I'm going to do it on router R1. And as before, let's just do a quick recap, a quick view on the routing table on router R5 before we've done this configuration. What I really want to point out is this I here. So that obviously stands for internal or iGP. It's really well trusted. So we could play about with any of these /32 networks. So I'm just going to focus in on the 18/32. So at the end, what we should see is E or question mark. Really, it's going to be the question mark because we don't use E anymore. It's the incomplete or unknown code that we actually use. So what do you need to do to actually configure this? Well, on router R1, where I'm going to do the configuration, I'm just going to go into Edit, Policy Options, Policy Statement, and I'm just going to call this Origin Code for obvious reasons. And now I'm just going to do set term 1, then, and if I hit question mark, then what you can see here is origin, i.e. the BGP path origin. That is exactly what we actually need to do. So I'm going to say origin. Now if I hit question mark, now we get those 3 BGP origin codes. So we got iGP, so path originated in the local iGP, or incomplete, so the path was learned by some other means, so OSPF, ISIS, RIP, static routing, or EGP. This is the one that is completely not used anymore. So I'm just going to do origin incomplete. And now if I do show, you can see it looks okay, but it isn't very specific, is it? Because we're just saying, well, just make it code incomplete. As I said, I want to focus in 18/18/18/32, i.e. R18. I want to single it out and I want to make that an unknown, an incomplete origin code. So now to do that, I do set term 1 from root filter 18/18/18/18/32 exactly. And now if I do show, it looks pretty good now, doesn't it? But I probably now just want to say then accept as well, because I don't want any other action to take place. So I'm going to do set term 1, then accept, do show, and this looks really good to me now. So set term 1 from this particular root filter, i.e. 18/32 exactly. I am then going to apply the incomplete origin code, accepting everything else. And that is the first part. How quick and easy is that? Now what we need to do is export that into BGP. Where are we going to export that? We're going to export that into the external group. R1 has an external group, iBGP neighborship and adjacency to R5 over this link here. So we're not going to apply it into iBGP because then that would be advertised throughout autonomous system number 1. No, we need to do it on the iBGP. So when Enterprise A R5 learns of the 18/32 network, i.e. the destination, it knows it's incomplete, it's unknown, and it will then let all other routers know in autonomous system 65100 know of its origin code. So let's go to the top and do edit protocols BGP group, and I called it external 65100. Let's do a quick show so you can see what's configured. So I've got time to live for 255. This is for the generalized TTL security mechanism. If you don't know what that's about, check out this link. Who I'm peering to, what's the neighbor's IP address, and its type external. Now all I need to do is say set export origin code. Let's do a show again, and you can see that's now part of that export list that I'm actually doing. So let's commit and quit this configuration. And so now we're back on router R5, which is in Enterprise A. Now this is the before, so we've got 18/32, and we could see it came through autonomous system 1, through autonomous system number 1. That's referring back to the point I made earlier in this video, and originated from 65200 with an origin code of I, or internal IGP, tongue twister again. So let's do that same command again, show route. And so now using that same command, I show route, we can see the after. So we've got the 18/32, and what you can see here is it's actually changed its path preference. What I mean by that is before I made that configuration, router R5 was preferring to get to the 18/32, it was going this way. But now, looking at the table, what you can see is it's actually preferring, because of that asterisk, the path through service provider 2, service provider 3, where it locally originated. Why? It's because of what's happened on R1, what we've done on R1. If you look just here, you can actually see now that the route through autonomous system 1 and again autonomous system number 1 to get to that destination of 65200, it's now incomplete, it's unknown. And as I said, I will always be preferable over E. E will always be preferable over question mark. I's the highest preference in terms of origin code. Question mark is the least preferable of all the origin codes. And as such, what R5 is now doing is saying, well, if I want to get to 18/32, I'm not going to go this way. And so I just removed secure CRT so you can actually see the actual preferred path that it's going. So it's actually going to go down to this router here, then into service provider 2, through service provider 3 and into Enterprise B before it eventually goes up to R18 at the top. And that really comes back to my point that I made early on, where we can actually change, manipulate, alter the router's decision in terms of where it's going to forward those packets to get to that end destination just by changing that origin code. And so just to recap on that, so what we've actually done is said 18/32 on router R1 here. I've made that incomplete from this destination. We don't know where it's come from. It's incomplete, it's unknown. And as such, because of this asterisk, router R5 is preferring out of the GigE002 interface, which is this interface here, to the next hop of 192.168.10.10, which is this interface down here, saying, well, actually, to get to this destination, I'd rather take the long route because it's internally learned. Even though the path is configuration-wise the same, when in reality it's not, it trusts it more because it's known, it is internal, whereas a question mark is the least preferred. And so there we go, everybody. That's the end of this video. I hope you found that useful. Hope you found it informative. If you did, please give it a like. Also, please subscribe so you can stay up to date with all the latest and greatest videos that I release weekly. But in summary, what we've gone through first is that AS path. We've shown on Juniper Junos devices how we can manipulate and expand or increase increment that AS path so that routers in a different autonomous system can make different routing decisions on what path or route they prefer based on that length. The shorter the path, the more preferable it is, because the fewer autonomous systems that packet will go through to get to whatever destination is at the end. But then we actually went on to origin code, discussed the 3 different types of the codes themselves, I for internal or IGP, EGP, which is never used anymore, and then the question mark incomplete or unknown. And again, we went on the Juniper Junos devices and showed really how quick and easy it is to manipulate, change, alter that code. So again, routers in a different autonomous system can change their routing decision based on that code itself. So again, I hope you found that useful. Stay tuned for the next video where we're going to go into even more detail into the BGP path selection process. Thanks for watching and goodbye.